Page 414, number 9. Solve the triangle. We're given two angles, angle A, angle C, and we're given side A. Well, let's start by making a sketch. And since angle A is obtuse, I'm just going to reflect that in the sketch that I make of this triangle. So angle A we know is 102.4 degrees. We'll call this angle C, which is 16.7 degrees, and we'll call this angle B. Now we know that the sides opposite these angles are represented with lowercase letters. So I know side A is 21.6. I don't know side B, I don't know side C. Now what we're given here is angle, angle, side. Since we know a side and the opposite angle, I can use the law of sines. So we're going to need to solve for this missing angle and these two missing sides. Let's start with the easy one here. I can solve for angle B because I know that the three angles of any triangle add up to 180 degrees. So I'm going to get my calculator out here, and let's just say 180, and I can subtract the two angles that I know, 102.4, and I can subtract 16.7. So the missing angle, angle B, must be 60.9 degrees. Okay, let's keep our calculator handy because we're going to need it to find side C and side B. Well, the law of sines tells me that any side divided by the sine of the opposite angle is always a constant. So I can say 21.6, the side that I know, divided by the sine of the opposite angle, the sine of 102.4 degrees, is equal to any other side. So let's go with side C, divided by the sine of the opposite angle, so the sine of 16.7 degrees. And by cross multiplying here, I can say 21.6 times the sine of 16.7. Then if I divide by the sine of 102.4, I'll know C. So let's do that. So I'll go 21.6 times the sine of 16.7 degrees. Then I'll divide right away by the sine of 102.4 degrees. And when I hit enter, I get that C is approximately equal to, let's go two decimal places here, 6.36. Now I can set up a similar proportion to solve for side B. I can say that, hey, I know 21.6 over the sine of 102.4 degrees is always constant. So that is equal to, and I can say side B divided by the sine of angle B, which we found up here. So the sine of 60.9 degrees. So I can set up the same kind of proportion. In fact, I'm going to do the same kind of calculation. 21.6 times the sine of, in this case, we'll say 60.9 degrees, divided by the sine of 102.4 degrees, gives me side B, which is about equal to 19.32. Now, to check my work here, I should notice that the biggest side is always opposite the biggest angle. The smallest side is always opposite the smallest angle. If that's the case, I'm pretty sure I've got the correct answer.